Hi, my dear nuclear scientists and nuclear engineers. This is continuation of Glasstone and Sesonske book. And in this video, different types of the reactor with schematic diagram. I have explained it. Keep watching. This is the simplest diagram for the nuclear reactor. This is a reactor core. It contains the fuel. These are the rods, control rods, which will control the fission chain reaction. And this is water or coolant which is passing through the fuel. And it will remove the heat from the fuel or core. And this hot water coming out, cold water going inside the reactor, passing through the fuel bundles or fuel assemblies, and that water becomes very hot. That hot water is going to a steam generator and it will reject the heat in the steam generator, becomes cold, and cold water again enters the reactor core and again comes back. It is a cyclic loop. It happens continuously because of this pump. Now here the steam is produced because it is filled with water and steam produced. The steam is going to the turbine and rotate the turbine and condense back to the, again it becomes water and enter into the steam generator. Again it becomes a steam and go to the turbine, rotate the turbine and comes back. This is also cyclic. Okay, this is simple schematic diagram for the nuclear reactor. Next, now what we will see, some different types of reactors I told no. Pressurized water reactor. What is the diagram? I will show now. Now what you are seeing is pressurized water reactor. So this is the reactor core. From the top, the rods are going inside to control the chain reaction. From here, the water is entering and removing the heat from the fuel bundles or fuel assemblies, and that hot water coming out from the reactor core like this, and it will go to the steam generator. This is the steam generator filled with water. This is the hot water going inside, reject the heat and becomes cold, comes back, again joins to the reactor core and again remove the heat, becomes hot and comes back. This is a continuous process. Okay, so this is the reactor vessel. This is shroud which will separate the reactor core and coolant. This is the core. So here we have to maintain some pressure, because water boils at 100 degrees Celsius at atmospheric pressure, but here temperature reaches more than 250-300 degrees also. Still it should and must be in the water state or liquid state, so you have to maintain the pressure. That is why it is a pressurized water reactor. The pressure here is inside the reactor core. When this hot water is coming out, now here the pressure we maintained around 15.5 megapascal, and again it is going inside here. No, the steam also, the steam generator also maintain a pressure around 7.6 megapascal. So after this it is same only. From here steam is going out, go to the turbine, rotate the turbine, because turbine is connected to the generator. From the generator you are producing the electricity. So ultimately it is rotating the turbine. After rotating the turbine, it will become again water, condense. It will condense and again joins back to the steam generator. It is again a cyclic loop. So pressurized water reactor means here two loops are there. One is which is passing to the reactor core and goes to the steam generator and comes back to the reactor core. Another loop is steam will go to the turbine, rotate the turbine and comes back, condense, again comes back to the steam generator. It is another loop. Okay, but they are maintained different pressure. Here is around 15.5 megapascal. Here pressure is around 7.6 megapascal. This is schematic diagram for pressurized water reactor. This is boiling water reactor. Why it is boiling water reactor? Why we are calling boiling water? Because inside the reactor the water is boiling. This is the reactor. It contains the core, coolant and moderator. Here coolant and moderator both are same. So water is coming here and it becomes very hot and becomes boil. The water becomes boil, means it becomes steam. After this steam again go to the turbine, rotate the turbine and again condense back and again it join the reactor core. This is cyclic process. So compared to pressurized water reactor and boiling water reactor, the major difference in boiling water reactor, the reactor itself is a boiler. In pressurized water reactor, there is separate boiler is there, steam generator is there. Here my reactor itself, it includes boiler. But boiling takes place at the top portion of the reactor core. This is the reactor core. So cold water coming from here passes through the fuel bundles, becomes very hot. Again here what happens, it becomes the steam. One steam separator is there and steam will go to turbine, rotate. So here we have to maintain some pressure. The pressure is around 7.24 megapascal. 7.24 megapascal pressure we are maintaining inside. Okay. The temperature will be around 289 degrees Celsius. When it comes here, when it becomes a steam, the temperature will be around 289 degrees Celsius. So you have to maintain high pressure around 7.24 megapascal. Then only we can go to the temperature of around 289 degrees Celsius. Okay. So here what you have to understand is this moderator and coolant both are same. If it is boiling more, it will add negative reactivity because it has to thermalize the neutrons. So it can control, self-controlled we can say. If power is increased, more boiling takes place. That time the moderation decreases and power will come down accordingly. So self-controlled reactor, this boiling water reactor we can say. So here we have a pump, it is recirculating the existing water, recirculating. Okay, this is also another pump, recirculating. It is like this, both the sides, these are recirculating pumps, because we have to maintain always the reactor core must be inside the water. Above the reactor core only the water will be boiled. So this boiled water, that is nothing but steam go to the turbine, rotates the turbine and condense and comes back here. So it will maintain this water level always above this reactor core. But complete water will not boil, only 14%, 1/4. Only 14% of the total water inside the reactor core will be boiled. That is the design. Okay, this is boiling water reactor. Now you understood what is general diagram for the nuclear reactor and pressurized water reactor and boiling water reactor. This is another topic from same Glasstone and Sesonske book. History of reactor development. After discovering the fission reaction in 1939, they did not immediately went for design and construction of the nuclear reactor for power production. This 1939 time is in the somewhere middle time between starting of the World War II and ending of the World War II. The World War II started 1st September in 1939 and ended 2nd September 1945. Around 6 years, 1 day, the World War II was happening that time. So that time, what they thought is, by seeing this fission reaction, they are thinking, use this nuclear fuel for nuclear power program. So first they focused design a reactor, construct a reactor, operate for some sufficient time, and produce plutonium 239 for nuclear weapons. So, to construct the nuclear reactor, first you have to maintain the chain reaction. This chain reaction maintaining, first time they have done that experiment in Chicago University. Finally, they have succeeded by maintaining the chain reaction by using the nuclear fuel. In 1942, in December, they have done this experiment and they have succeeded. So, after getting the confidence, maintaining the chain reaction and maintaining the power of the nuclear reactor, they have constructed one nuclear reactor around 1000 kilowatt power with uranium metal fuel and graphite as a moderator, air cooled. This they have done around 1943. After a year, they were doing a lot of experiments and they were successful in designing, constructing of the reactor with water coolant also. Okay. So after 1944, up to 10 years, from 1944 to plus 10 years, they were doing lot of experiments so that they can get lot of confidence designing, constructing of the nuclear reactors. They were doing lot of experiments. Okay. So first one, the United States, before going to construct the nuclear reactor for electrical power generation, they were thinking these reactors for submarine. Why? The submarine in the sea, it has to stay for a long time, it has to travel a long distance, it has to travel with the high speed. So first they focused the submarine reactor program. For that they were doing lot of experiments. They have finally come out with a particular successful design, that is pressurized water reactor. This pressurized water reactor is, the fuel is enriched uranium dioxide and pressurized water as a moderator and coolant. So first time they started this submarine reactor program in 1948. After few years doing lot of experiments, gaining the knowledge, finally they succeeded this project in 1955 January. First time the nuclear powered submarine, they have first trial they have done in the sea in 1955. 1955 they have done. So the name of first nuclear powered submarine is USS Nautilus. After they are gaining lot of confidence from the submarine reactor program, they focus for electrical power production by using nuclear reactor. So most of the reactors in the world which produces the electrical power, they are using the similar technology of PWR. PWR means pressurized water reactor. Okay. Other than PWR, some other types of nuclear reactors also designed. Boiling water reactor. They have done experimental boiling water reactor. What is that? Already I explained. Within the reactor core, the water is boiling water reactor. In the world, the significant portion of electrical power generated by the nuclear reactor, also by the BWR, boiling water reactor. Okay, in United Kingdom they have done some experiments. They also design a new reactors, gas cooled reactors, enriched uranium or plutonium fuel they used, graphite as a moderator, coolant, cooling purpose they used gases like carbon dioxide, pressurized carbon dioxide, like that they have done. In United States also, Germany also, they also tried gas cooled reactors, helium coolant also they used. And another important thing, they have done a lot of experiments regarding fast neutron reactors also. What is fast neutron reactor? Fast neutron reactor means the chain reaction maintained by fast neutron. The fast neutron means the energy of the neutron around 0.1 mega electron volt. So what is the advantage of this? This fast neutron reactors, the main intention is to breed the nuclear fuel. Breeding means when you are consuming the fuel is produced. That is the beauty. So breeder reactor, what happened? This fast neutron breeder reactor, neutron captured in the uranium-238, that uranium-238 will undergo beta decay. It will become convert into neptunium, and further neptunium undergo beta decay. Finally, it will become plutonium-239, which is very good nuclear fuel. The main intention of this fast neutron reactor is for breeding purpose. That EBR, experimental breeder reactor, they have successfully operated for 30 years in Idaho in United States. EBR2 rated capacity of 20 megawatt electric. They have operated from 1961 onwards, 30 years they operated successfully. This reactor, after that they decommissioned. So they got a confident with this technology or with this principle, with this formula, with this concept, we can design, construct a fast neutron reactor that is proven. So this is the history of reactor development. The last topic of this chapter, what is the role of computer? Why we need a computer in nuclear reactor engineering? Already we discussed nuclear reactor means it's a core, contains a fuel, moderator and coolant. Fission reaction starts, heat produces, remove the heat, produce the steam, rotate the turbine, produce the electricity. It is very simple by saying and by listening. But in fact, to design a reactor, it's very difficult. Because what is happening in the system, first you should be able to understand. What is happening in the fission reaction, you should know. What is the fuel? What is the quantity of fissile material? And how many neutrons are producing? If you are taking some critical mass, I told no, what is happening in that mass? So ultimately fission is happening, neutrons are producing and neutrons are moving from one place to another place. They are accumulating a lot, neutron flux we call, number of neutrons per centimeter square area per second. So these neutrons are moving from one place to another place within that medium. They are diffusing, high concentration to low concentration. When they are diffusing, they are moving from one place to another place. They are interacting with uranium, some other structural materials also. Lot of things are happening. So you should and must able to find out what is the neutron flux at each location. This neutron flux, why we want? If you know the flux, if you know the neutron flux, How that neutron flux is, the neutrons are participating in chain reaction, the reaction rate taking place, so that we can find out how much power is producing from the fuel assembly or fuel bundle. So to estimate the power produced by fuel assembly or fuel bundle at different location, at all the locations inside the reactor, we need to have some calculations should and must be carried out by a sophisticated machine, that is our computer. Because a single second order differential equation, diffusion equation, you may solve with your pen and your book, but in such a huge locations, huge points, huge variables are there. So it's very difficult to solve that equation, to find out the neutron flux at different location in the reactor. So we should and must use the computer. So that is the most important role of computer, to solve the mathematical equations, estimate the neutron flux, estimate the power, and etc. Okay, so with this, the first chapter of Glasstone and Sesonske book is completed. I hope you are understanding 100% from my videos. Next chapter I will start very soon. Till next video, bye bye.